In this question here, we're asked to figure out the total pressure of a mixture of gases based off the partial pressure of our diatomic gas. Well, the first thing we need to do is figure out which ones are the diatomic gases right here. So that would be these green ones because there's two, like it's represented with two atoms in this picture. So it's saying the partial pressure of the diatomic gas is 0.3 atmospheres. What is the total pressure? Well, the first thing you need to do is you need to figure out how many, well, I'm just going to label these out. So we have three diatomic. We have 1, 2, 3, 4, 5, 6 blue, and 1, 2, 3, 4, 5 orange. Okay, so in this representation, we have a total of 14 molecules of a gas of a mixture of gases. Now the first thing we're going to, after we do that, what we're going to need to do is figure out what we call the mole fraction. So the mole fraction is what it sounds like. So if we have 3 of our diatomic gas out of the 14, that will give us the mole fraction. It's almost like a percent. So that's for green. For blue, it would be 6 out of 14, and then for orange, 5 out of 14. So we'll figure out the mole fractions like this. So 3 divided by 14, 0.214, 6 divided by 14, 0.428, 5 divided by 14, 0.357. So we figured out all 3 of those, but we're only concerned with the green one at this point. So what we can do from there to figure out the total pressure is we have a formula we can use. And what that says is the partial pressure is going to be equal to the total pressure. Write that the same way. Times our mole fraction. Okay, so if we know the partial pressure and the mole fraction, we can figure out the total pressure. So for our diatomic gas, the partial pressure was 0.3 atmospheres. Total is what we're solving for, and our mole fraction, 0.214. Divide these out. 1.4 atmospheres would be the total pressure of 1.4 atmospheres would be the total pressure of this mixture of gases. So we can take this a step further and we can say, okay, well, we know the total pressure of this mixture of gases. We can also figure out what the partial pressure of these are. So if we know the total pressure is 1.4 times the mole fraction for these blue molecules, we can do 1.4 times 0.428. So we know that, I'm just going to say 0.6. So 0.6 would be the partial pressure of blue. And then for orange, we would have 1.4 times 0.357. we would get 0.5. Okay, now, excuse me. So now we have three different pressures right here. So this is for the orange, blue, and then we have 0.3 atmospheres for the green. Okay, so we have these three right here. Now, Dalton's law of partial pressure says that the total is equal to the sum of all partial pressures. So if we wanted to go back and check, what we could do is our total pressure should be 1.4 atmospheres. So if we add 0.5 plus 0.3 plus 0.6, we get 1.4. So we can go back and check it like that. So we can figure out the partial pressures of each of them and compare, and then add those up together and see how that compares to the total pressure that we calculated.